Hello, everybody, and welcome to the second lesson for today. Learning target here is I can determine if two figures are similar or not. And so we talked about similarity, right? It's when two figures are the same figures, but one's bigger than the other. Like we see here, the one on the right is bigger than the one on the left. But notice, they still have the same angle measures. And so if we were to look at angle C and compare it to angle F, they're both 40 degrees. Just like angle E and angle B would both be 75 degrees, and both angle A and angle D would be 65 degrees. So they have the same angle measures. And then the next part is that the sides are in proportion to each other, which means that the ratios of each pair of corresponding sides are equivalent. And what we're going to do is take a look at some vocabulary here to kind of clear that up. So if we're going to look at the essential vocabulary, we're going to start off with corresponding sides and corresponding angles, what we just did on that first part of the packet. And we see that corresponding sides over here on the left side of our screen, that would be like AB and EF. Next we have BD and FH. And basically it's just saying that these sides are in the same relative position as the other shape. Next we have the angles that correspond with each other. So it'd be like angle A and angle E, angle B and angle F. All right. Then we look at ratios. So we talked a lot about ratios the last few days. And here we have, it's a comparison of two quantities, often written as a fraction. So one number over the other. And equivalent ratios are when both fractions can be reduced to the same simplest form fraction. So what that's saying here is if we take a look at the side length of QR to start. Okay, so I have QR. That is 9. And then I look at the other shape with the corresponding side, which would be L to M, right there in the same position. That's 12. And so we have 9 over 12. And if we were to reduce that to the simplest form, it would be 3 over 4. And then if we take a look at another side here, let's say RS, well then we're looking at which side corresponds with RS. It'd be MN. So RS side length is 6, MN is 8, so we have 6 over 8. And again, that reduces to 3 over 4. So notice both QR over LM reduces to 3 over 4. And also RS over MN reduces to 3 over 4. So let's go ahead and take a look at the final side here. We have QS, side QS, to side LN. Those are the ones that correspond with each other. They're in the same relative position. Okay. QS, which we're going to write on top here, is 3. And LN, which we're going to write on the bottom here, is 4. So notice, all of the ratios, when we put them in simplest form, it's 3 over 4. So they all reduce to the same number. Therefore, we can say that the ratios are in proportion. That's the equality of two ratios. So we have 3 examples here. So we see that 60 over 100 is equal to 3 over 5. We see that 1 over 2 is equal to 5 over 10. And finally, we see that x plus 5 is equal to 3 over 10. Okay? We don't know if those are equivalent yet. We don't know what x is, but we know that those first 2 examples are, in fact, equivalent. If these are equivalent, because we see the equal sign, then we can figure, okay, here we had to divide 20 by 2 to get to 10, so we'd have to divide this top number by 2 as well. So this would have to be 6. Therefore, x would equal 1. 1 plus 5 equals 6. All right, so that's like how you could solve there. And if now we're going to look at scale drawings, that's something we're going to get to later on, but just a quick briefing of it. It's when you take a look at how you get from like 2.8 on the, or 2 inches on the top to 8.5 inches. It's like, what would you have to multiply 2 by to get to 8.5? And then you do the same thing on the bottom. Multiply that bottom number by what you multiply the top number by. So we're going to get to that later on, but not today. All right, so here we go. Back to the packet.